is a simple neural network. The basic unit of a neural network is called a neuron. In this diagram, the neurons are represented by the circles you see on the screen. These neurons need to be connected to form a network as shown by the lines connecting them together on the screen. These connections between them is what allow information to flow from one neuron to another. In a neural network, the neurons are grouped into three main sections. The first section is the input layer. This is where the network receives data, and the data that is being received by this layer is used to train the network so that it can make good predictions. The middle layer in the neural network is called the hidden layer. This is where the actual learning and training happens. And during the training phase, the network performs many mathematical operations in this layer to help recognize patterns in the data that was received by the input layer. Then we have the last layer, which is the output layer. This layer produces the final result or predictions of the network. Now, you may have noticed that in this simple network, the input layer has just 2 neurons, the hidden layer has 3, and the output layer has 1. You might be wondering why these numbers. Is there a specific rule for choosing the number of neurons in each layer? The truth is, this network is just a basic illustration to explain the concept. But in real applications, the number of neurons in each layer actually depends on the problem the network is trying to solve. The input layer size is determined by the amount of data being fed into the network. The hidden layers can have different numbers of neurons to help the network recognize patterns, and the output layer changes based on what kind of prediction the network needs to make. Now, let's look at a real-world example of a neural network that is trained to recognize hand digits. To a human, this is just a number we recognize instantly as number 9. But for a computer, this digit is just an image, nothing more than a collection of pixels. In this case, the image is 20 by 20 pixels, making a total of 400 pixels. But how does a computer see these pixels? Unlike us, computers don't see images as shapes or colors. Instead, they store each pixel as a numerical value. For grayscale images like this, each pixel is represented by a value between 0 and 255. A pixel with a value of 0 is completely black, while a pixel with a value of 255 is completely white. And any number in between represents different shades of gray. These numbers are what the neural network processes as input. Now let's see how this data flows through the neural network. Each of the 400 pixels in the image is assigned to a neuron in the input layer. That means the input layer of our network has exactly 400 neurons, each receiving a pixel's numerical value. Once the data enters the network, the neurons in the input layer send their values to the next layer. The network then processes this information by doing calculations to find patterns in the image. It looks at the different shades of gray in the pixels and searches for features that help it recognize the number in the image. The neurons in the hidden layer that detect important patterns then get lightened up. As the data reaches the output layer, the neuron representing the number 9 has the highest activation. This means the network predicts that the input image is the digit 9.